All right, over to you.
All right. Thank you so much, Lorelli, and thank you everybody for joining. Hope you had a good morning. I know I took a quick jog and excited to build quite a few things in the cloud today. So I think it was about 2 weeks ago, we had a webinar and we talked about secure service networking and how secure service networking differs from service mesh and really how it is a complete solution and the different use cases. And then we looked at that through the paradigm of zero trust. So what we're going to do today is just the really quick version of going back through what we talked about for those that couldn't make it. And after we go back through it, we're actually going to do it. We're going to do a 4-hour workshop and we're going to build what we said we'd build across lots of different runtimes, lots of different clouds. All right. So quick introduction, Lorelli, thank you for that. I am Greg, work here at HashiCorp, support intelligence community and Department of Defense with emerging products for HashiCorp Federal. All right, so the questions we're going to answer today, let me get my laser pointer, are where are my services running? When we say services, we're talking about business or mission applications that are running in a LAN or a WAN somewhere. Where are those services running? Being able to discover those services, right? Next is how do I communicate between those services, whether those are machine-to-machine, non-persona entities, or whether those are humans needing to communicate to a machine. And then how do I automate routine networking tasks? So, as you have, whether it's AWS security groups or firewalls or, different IP tables, lots of different routine things that you might have to do and that were very manual and intensive. How do you offload some of those things? And then how do you control access to environment? So authentication authorization for everything. How do you cryptographically prove, things for service identities versus just IP addresses? All right. So when we look at the universal principles of zero trust, I published a blog. If somebody puts it in the chat, if you guys haven't saw it, did a little bit of discourse on this and actually lucky enough to volunteer with NIST, the National Industry Standards and Technology, and, kind of floated the article around and got some feedback. But I think more or less everybody pretty much agrees that these universal principles exist, saying that, zero trust is identity driven, right? Mutually authenticated, whether that is through MTLS, cryptography, or what? Everything needs to be authorized, time-bound, encrypted at transit and rest, have data protection, advanced data protection in some scenarios, and everything needs to be audited and logged coherently. Principles applied to these are, how do you access things and how do they communicate, like machine to machine? All right. So quick reference model, and today we put a kind of a touch on this and a focused workshop for Department of Defense. So for those of you that don't know this acronym here, this kind of acronym soup, this is DISA, the Defense Information Systems Agency, right? And then NSA, National Security Agency. This is a reference guide that was published, and it talks about devices, authentication, authorization, compliance. Over here in the network side, it talks about software-defined networking, macro segmentation, and all these good things. But if you see this arrow here, it shows encryption across a lot. And what I kind of see as I go around and see a lot of people around the world is that they're lacking an ICAM workflow, right? A way to do cryptography across all these different, I guess these are kind of a taxonomy, right? And then today, what are we going to do? Right? We're just going to do it instead of kind of talking about it. We're going to show how all these different, taxonomies can be used, right? With using, HashiCorp Vault and Consul. We're also going to use some Terraform and Nomad today, but those are just to make our life easier. All these tools stand on their own, as far as following the Unix philosophy, but just through a lot of, turmoil, if you don't have a way to provision infrastructure, run it, it can become really complex, as we'll see today in the workshop. Okay, so shifting from the static environment that we see a lot within Department of Defense, a lot of places where there was high trust or clear network perimeters, castle and moat, right? We see things are security is really being enforced by IP addresses. You have to do whether it's called the BCR or whatever it is, you have to have a a list of IP addresses that are only approved, right? So you're trusting this IP address, whether that's an IP address on the other side of an IPsec tunnel for VPN, or whether you're just trusting that from, you know, a firewall or something like that. You're trusting an IP, okay? And what we've done is we shifted to this low trust, you know, not just in the public cloud, right? This could be still on-prem in a closed environment that has no ports or protocols open to the world, but we still want security enforced by identity, right? We want things to be cryptographically proven and follow those universal principles that I wrote about and we just discussed. All right, so I really like this slide because a lot of times people are like, excuse me, mouth's getting dry here, going on 4 times speed so we can get to the workshop. But a lot of times people are like, hey, Greg, so Vault, does it just manage passwords? And there's like a, you know, 1Pass or something. Like, definitely not. So we're missing kind of the bottom of the iceberg of what Vault actually provides, right? So we talked about Vault solving 2 problems, right? So it solves the problem of secret sprawl, and we define as a secret as anything that can be used or taken to compromise the system. And then also solves a problem that we talked about with the universal principles of zero trust for identity, right? Being able to use those service identities or different identities from machines or non-persona entities to communicate. So you see like and a lot of times those trust anchors could be your X509, your PKI certs, lots of different keys, you know, and lots of different methods, right? And these are engines or methods involved. And we talked about that during the webinar. Okay, so quick refresher here. What is a secret? Up here, you see, you know, the sensitive info, right? The CAC, user passwords, tokens, crypto keys, certificates. Who needs to access these things? These NPs, right? Non-persona entities is defined by NIST. They need to access secrets. Humans want to access secrets, right? Think back to that workflow. How is the cryptography? How are you keeping that compliant with the Federal Information Protection Systems 140-2, which is the standard, right, for cryptography? I hope you're not going on Stack Overflow and Googling it and trying to use some cryptography from there. You definitely want to have a structured system and way that you can automate and scale, you know, that security system. We talked about that as well. All right, quick intro to Consul again, before we dive back in. The main things that we're going to look at today, one of them would be service discovery. Okay, how does service discovery work? All right, so you're taking IP addresses and mapping them to DNS. First, you have to have things registered in a service registry with a service catalog. Once they're registered, then you're able to discover services. When you can discover services, then you can start using trusted service identities. And then we're moving over here into your multi-platform service mesh, right? So we'll talk about mesh gateways. Mesh gateways are how you can connect 2 different WANs on any different runtime. For your north and south traffic now, Consul, we have Consul API Gateway, getting really, really popular. There's you know, egress gateways and stuff like that, or ingress gateways, and we'll discuss. But in general, this is your service mesh, right? And we talked about secure service networking. So that's this whole solution, right? That's the difference from just having a service mesh that works only in one runtime like Kubernetes. When we get over here, the NIA, Network Infrastructure Automation, we are going to dabble in that today. Everything that we do, we're going to stand things up in Google, AWS, and Azure. Everything that we stand up, we'll use Terraform, and then we'll use network infrastructure automation to automate the whole process. So instead of somebody like having to go in and change a security group or a firewall rule, that source of truth will actually be in Terraform, and it'll just update in real time, saving us tons of money for our business and driving us to quicker, you know, mission effects. All right, so this is kind of what it looks like for CTS. I do have that cool logo back in here. Marketing, Lorelli, apologize. I know this is an official logo, but I was a gamer. Josh Tracy joined me in the last webinar and, you know, works with the Terraform team. So we had a little fun with this, but this is what we said we were going to do. And it's generally the same model. We updated a little bit for today. All right, so real quick overview of just kind of holistically what we're about to build. So we have machine authentication authorization with really these use cases, right? Identity broker, machine service, root PKI, secrets management, right? Machine to machine access with Consul, and then Consul Terraform sync. So we're gonna, you know, push a button, all this will get stood up. as it gets stood up, it'll go within Consul and it'll take all that network infrastructure and it'll automate it, right? So that it comes back to the source of truth. All right. So let's get into the lab. But before we do that, I have a quick couple admin notes just to orient you and make sure everybody's set up for success. First thing is, I know I've been a user and a customer of HashiCorp for quite a few years. And I remember coming to these webinars when I was in your seat, and I was like always asking, hey, can I have that webinar just till Saturday? Because I know I have a high bog rate and I can talk kind of fast. So I did, I gave you this lab till Saturday. So if you want to do it again on Saturday morning or whatever the case, you'll be able to do that. Thank you, Lorelli, just posted it in the link. We did send that out in advance, but I know how email is. I never check it. So there it is. And we did hot load it. Normally, if you do this after today, it'll take like about 23 minutes to build. But I have everything loaded, so it should just come right up. If it doesn't, please post in the chat and we'll get one of our teammates to help you out immediately. All right, so again, quick recap about the workshop. We're going to do multi-cloud, multi-region, multi-runtime. We're going to combine containers and VMs, bare metal workloads, and we're going to extend the service mesh to external services. All right, another admin note, this is not a comprehensive tutorial on how to run Consul Enterprise. If you want to run Consul Enterprise in production, please contact myself and I will help you to build a solution, and it will be a lot of fun. All right, in this workshop, we're going to make use of several complementary tools. We're going to use Terraform, Vault, and Nomad, but again, I want to say none of these are strictly necessary to run Consul Enterprise. It just makes it a lot easier. All right, so this is the app we're going to build, and I will wait a minute and see where everybody's at. I'm going to go ahead and check in the chat. Could everybody raise their hand if they're not able to pull up the screen and kind of get where I'm at? Because this is a 354-minute workshop today, so I definitely want to get into it. Got quite a bit to build. All right, I'll just pause for a minute. Okay, I see a raised hand. All right, hi Jessica, all set, okay, good. All right. All right, we'll wait another 30 seconds. Good, okay. Okay, getting 404. Okay. What browser are you on, Derek? Chrome, okay. Did you add instruct to your workshop first? Okay. All right, Lorelli, if you could do a breakout room for anybody that's having the, I'm not using the URL that Lorelli supplied. Oh, okay.
Oh.
Maybe if you could do a breakout room so we could try and help them, and then we're gonna, I am using URL, just getting 404. Did you add instruct first? A lot of times you'll see a 404 error if you don't have instruct. So the steps are to, that were sent out in the email to get the instruct account. After you use the instruct account, and then use the link from the email. There you go, Jessica's got it. Thank you, Jessica. Jessica, would you be kind enough to post that in the chat, or Lorelli, if you could get the link that was sent out in the email, that'd be the correct way.
Yeah, let me go grab that real quick.
Okay. All right, thanks. Oh, there it is. Thank you so much, Jessica. Okay, for everybody else in the audience, just as we wait, we'll kind of look at the overall architecture. So this is the sandbox, and like I said, you're welcome to come in here and try some different things with this up until Saturday. But what we have inside of the lab is 3 different cloud service providers. Not saying that, you know, we recommend trying to run things on 3 different clouds. It's just the point that a lot of times, you know, multi-cloud is not something that, you know, that we're after. It just happens. You end up having to, you know, be able to access different things. And it is really helpful to have control points for provisioning, connecting, securing, and running across all of these different cloud service providers. I do want to highlight a couple things. When I say, or when we say mesh gateway right here, this is a Consul feature, right? This uses a Consul service instance. This is used for WAN communication in Consul. This is not a GKE, Google Kubernetes specific thing. This is just running in GKE. Over here, the mesh gateway is running on an AWS VM. So that just goes to show, okay, good, Derek's good to go now. That just goes to show that you can run Consul itself on any runtime as well. And when you come over here and look at this Azure VM, this is also running a mesh gateway. So these count as service instances. Inside, you can see that you're going to have different systems. You're going to have data systems running the HashiCorp app. You're going to have, you know, API front end systems. And all of these different systems are going to be running Consul. And they use Envoy as a service proxy. All right. In this lab, as we're going through, you can go ahead and look at this code. Feel free to use it, you know, per license. And then here's Packer. And then here's your Terraform code. You can go ahead and look at it. If you want to actually see your infrastructure getting stood up, you can go ahead and click on account ID for each cloud service provider, and you'll see that. All right, so the first thing we're going to do is we're going to take a quick look at the image list. So Packer actually can help out a lot. A lot of the times, the challenge that we have is called, you know, security technical implementation guides, right? These STIGs. So a lot of times what you have to do is you have to have artifacts that you can, you know, mass reproduce with Packer. Great. I'm glad you're good. Thanks, VC. So with Packer, it helps you to be able to take the artifacts that are needed to attest, right, to approve to your different security controls. And in the commercial industry, those could be things like HIPAA, PCI, DSS. But in the, you know, in some of the military or different types of regulatory industries in the public sector, you can have things like NIST 800-53 Rev 4, Rev 5. And those specific requirements can lead to controls that are in, you know, 500 plus. So by using Packer, you can make sure that you have an image that really meets the needs, you know, and get your time to mission down to seconds, not months. So when you look at the VPCs, just a quick, you know, update. They're named a little bit differently, but these are basically your data centers, right? These are your data centers in Google. You know, your network list or your VNets or your VPCs for AWS. So all we're doing here is describing them. So you can go ahead and do that on your own and follow along. And I'm kind of looking at the chat. If one of these commands, if you have a question on one of the commands or it's not, you know, it's not working on your end, please let us know so that we can get you comfortable with it. All we're doing here is going to look inside of the Packer images, and we're kind of checking to see how those are structured. So, all right. So after we've done that, you can go ahead and look at your, you know, Packer build for each one of these, if you'd like. You will not need to rebuild the images unless you get an error again, okay? So you don't need to run those bottom commands unless you get an error. So go ahead and check. If you could just post if you're good in the chat, if you get it correct. And then if anybody needs additional help running Packer, let us know. Nice. All right, great. Good job, Charlie. Okay, yep, Charles is good. I'll just wait a couple seconds for everybody else. Also breaks as we wait for everybody else. Lorelli, please remind us. I know we get kind of excited doing this and can tend to go past breaks, but we're going to try and take a break, I think, on the top of the hour. So if you could just come off camera, remind us when it's time for break. Thank you. All right, there's good. Okay, I think we're good to go. If not, go ahead and stop me and we'll come back. All right, thanks, Lorelli. Okay. All right, so next thing we're going to do, I want to talk about Terraform, and I imagine I'm looking at the group here and I think everybody has a good understanding, but what we're doing here is Terraform is going to help us with immutability for all this different infrastructure, and give us a sound control point to provision it. Terraform plan is a way that we can actually plan and just confirm what we think is going to happen is going to happen, right? And I love Terraform plan. I know years ago when I started out with Terraform, it was really helpful to actually see what was happening and kind of just follow along and see what was going on. And also you can get it to give you lots of helpful human readable errors, that you are really easy to fix. Also, Terraform is written in HCL. I wrote a blog about that. Oh, hey, Anthony, how's it going? I'm following along via mobile. Okay. Yeah, no worries, Anthony. I know you're busy. Thanks for joining today. But yeah, I wrote an article in HCL, and HashiCorp language is actually, I wrote the article just out of frustration. I had to deal with a lot of helping people get their systems into production with YAML. And YAML, like debugging it with the spaces and all the stuff I wrote about in the article, was just really, really hard. And then, I don't know, like 5 years ago or so, I learned about Terraform, and I was like, what's HCL? And it didn't have to use YAML, and I could provision everything like that. And I just fell in love. So yeah, check it out. Terraform's pretty awesome. That's what I meant by push button and get, lots of different things and build 3 different clouds, at least stand up the data centers in 3 different clouds just by hitting this next command, which is Terraform auto apply and then auto approve. So you're just hitting the tac auto approve, which means that, you're okay. Otherwise, if you're curious, that's good that you're curious. If you don't do auto approve and you just do Terraform apply, you just apply the Terraform, and then it would ask you if you're sure. Common command, and you just have to say yes. But if you do auto approve, it'll just go ahead, and that'll take a minute. So VC, I see you still have your hand raised. Did you want to come off mic, or did you have a question, or was that still raised? Okay, thanks.
You're on mute, Greg.
Thanks, brother. I just said, yeah, at any time, if you have questions or want to speak up, please go ahead. Course is meant to be interactive. If you have any questions on anything. So if you want to tail the logs here, you can monitor with these commands, but no need. That went pretty quick. So once you're done, you can go ahead and check it. So you see there, when I say getting people down the seconds to provision their infrastructure, before you used to have to go through a whole STIG and meet all these different controls. Now you still have to do that, but you can use Packer to automate all those different STIG controls that you had, but you can use immutability with Terraform, which can provision all that infrastructure in seconds. So once you already have a STIG, no reason to recreate the wheel. You just use Terraform and Packer, and then push that button, and then all those different cloud service providers, infrastructure is provisioned and stood up with a control point that's immutable. So as you go through different versions or need to roll back from versions, you're able to, accelerate from version 1 to version 2, version 3, etc. So really helpful stuff. All right, so this will just take a minute to set up. Go ahead and hit start at the bottom right of your screen. All right, we're going to take a quick look at your Terraform. And basically what you're going to see here is Terraform for each one of the cloud service providers. And we'll take another look at the architecture here. Really no change. There is some different things that we're going to start to integrate here with the CTS workflow and then WAN federation. Kind of showing how with the WAN federation, like a service inside of here could reach into this cloud service provider and talk to a service inside of there. And that happens through the mesh gateway. One thing here the look out for is this is not based on IP address. So the old way of doing things like we talked about might be to whitelist an IP address, but this is just going to be a random IP. So something to consider for planning, that we're not just saying zero trust. It really is really based on, that cryptographic identity or trust anchor here with Vault. It's not based on an IP address coming through this WAN connection in the mesh gateway. So some think about there. So, all right. So in this assignment, we're going to create the trust with various runtime platforms. So I kind of just talked to you about, the why and showed you the architecture. But what we're talking about here is actually trust anchors. And when we say trust anchors, we mean, trust nothing, authenticate, and authorize everything, right? Vault is using cryptography that's proven, for mission needs with FIPS, right? So what we're going to do is we're going to ingrain a trust anchor in each one of these nodes. So think about these nodes. It could be, Vault agent can run on the edge. And when I say the edge, I mean where the X is at, where things are kinetic. It doesn't need to, reach out to different ports and protocols, communicate internally on 8200 or 8201. So Vault's really good for that. Now, as far as coming in here, we're going to go ahead and provision those trust anchors with the same methodology. So we're just going to go ahead and hit Terraform plan. And that'll just take a minute to provision our trust anchors. Checking the chat. Does anybody have a question about what trust anchors are and how those are going to be? I think you kind of see where this is going. Now we have the mesh gateway that's connecting these different WAN connections. We have Consul that's registering where, all the services are at with that basic use case. And then the more advanced use case is being able to make everything work as a service mesh, but not just a service mesh, right? We're using secure service networking across all these different cloud platforms, agnostically of what the runtime is or where the cloud's at. We're just connecting these mission applications using, cryptography as the trust anchor, and then using Consul as that way to map the IP addresses, the DNS names, discover them, and then route them through service mesh on both the LAN and the WAN. Okay. Any questions on that? There's also a link here for the Vault website. If you're like me, you would, and you were not familiar with this, you would now have a lot of questions. So the Vault website is right there. I did write in an article about how to learn HashiCorp, things. And if you did want to pursue making these anchors. Oh, okay. Good question, Jessica. So the code for making the trust anchors is right here in Terraform code. So it's within AWS, Terraform, Azure, GCP, and main. Right. And then Terraform also uses modules. So if you look inside of the .Terraform, you're going to see where the plugins are at, Jessica. So that like modules are really, really neat. So with Terraform Enterprise as well, you can also do private module registry. And that is something where you can have, you can leverage all the open source for Terraform, but say that you had just specific company modules that were approved, you could put those modules in the private module registry. So those could be like, company X, data center in Hawaii or data center in DC, and you could have a private module registry just for Hawaii or DC. All right, so that's done. Go ahead and check it. Oh, yeah, definitely. Good question, Derek. So a trust anchor in this case is if you're just simply if you're routing from WAN site 1 to WAN site 2, Derek, before, a lot of times the way that would work is you would use an IP address, right? You would have and say, I only IP address, X is able to access this WAN site, right? What happens a lot of times with like those sites, somebody gets in, attacks laterally, takes over that node, or they impersonate that IP address, or they do some kind of man in the middle attack against that, or they attack that IP, right? By using HashiCorp Vault, you're using cryptography, right? So you're not trusting the IP address. The IP address is never going away. TCP/IP networking is still alive and used. It's still there. What you're doing is that IP address is just mapping to a service identity, which is just using DNS, right? And then that service identity in Consul is actually using and working with Vault. So with Consul working with Vault, that cryptographic chain is proven on one side and then on the other side, right? So you're essentially ensuring that when that connection's made using, it is actually gossip encryption that you're using, so that you're making sure that that connection is secure. I see the anchors or the IAM rules and such. Yep. Awesome. Thanks, Derek. All right. This challenge takes just a minute longer. A little bit more infrastructure to stand up. VPCs or VNets always stand up really, really fast. I think just because they're probably used and they're free tier, so people are standing them up every minute around the world. And then obviously servers in the cloud are actually real things, so they have to power on. And okay, there it is. Awesome. Thanks, Derek. Yeah, so the cloud, you actually have to the cloud service providers has to power on those servers. This is really cool to think about. Every time I have to really just pinch myself and think how cool it is that we're just writing code on all these different buildings and places where the servers, the data centers are just being constructed that fast. Just really, really neat stuff. So what's happening right now is those servers are being built, and then inside of Terraform and Packer, we're standing up the Vault and the trust anchors inside so that we can make those service connections across the mesh gateways. And what was really neat about the mesh gateways is one of the mesh gateways is running in GKE, and GKE is actually Google, Kubernetes environment, I believe. Somebody correct me if I'm wrong, but I believe that's it. I use EKS and AKS a lot more. I haven't used GKE in a year or so besides this, but GKE is actually Kubernetes environment. So inside of the Kubernetes environment, you can run Consul using Helm. It's actually really, really easy to get started. There's just different annotations and everything and variables that you need to change in the values file and etc. To deploy Consul in these different mechanisms and ways. And you can actually use Terraform templates to deploy those Helm charts in an environment like we did. So that is what's getting stood up on the GKE side. On the AWS side, we just used VM. And the VMs on the AWS side are actually called EC2s. So we're just running Consul, that mesh gateway on EC2. And then on the Azure side, same thing. We're just using a VM, right? And I just call VMs on Azure. Maybe somebody in the chat can post if I'm wrong and it's not a VM. All right, start should be up. Okay. So next thing we're going to do in this assignment is we're going to start with secrets. Okay, so we talked about Vault solving two problems. The first problem we talked about was Vault solving the problem of secret sprawl. And we're going to get into that a little bit now. The second problem was with identity, right? We were talking about some of the different roles for that Terraform and stuff like that. So that's using Vault to solve, that connection or trust anchors with identity. Now, the second problem is, with secrets. So now the servers are available and the UI can be accessed. All right, so we get to take a look at what Vault looks like. So you can see here, this is licensed Vault. This is Vault Enterprise. So this is different. Vault comes in the open source. But you're definitely going to want to use Vault Enterprise for this. Lots of the features are only available in Vault Enterprise, like namespaces and many more that we'll talk about. But this is what Vault Enterprise looks like. As you play with this, you can come in here and kind of see some of the mechanisms. You'll be able to log in and you can create things in Vault, through the UI, through the CLI, or through the API. So there's 3 methods that you can use with pretty much all our products. Same thing with Consul. All right, so coming over here, we're going to check on the status of replication. Okay, so disaster recovery comes with Vault just out of the box for open source, but a lot of times what you're going to want to use is performance replication or replication. And what does that mean? That means how your secrets and your identity are replicated to other sites, right? So we were just checking on the replication there, and you can look at that and see if you have any questions. This output or this command, we'll just talk about this if you weren't familiar. Anytime you do a tag format for JSON, it's just giving you, the format in JSON. Otherwise, it's not going to be, that pretty. You don't have to output it in JSON if you don't want to. You can look at that, that output anyway. That is works for you. All right, so the next thing we're going to talk about is Vault commands. So there is a thorough reference for this, but most or all the Vault commands start with Vault, right? So the first thing we're going to do is log in. Now we could log into the Vault console. You can log into the Vault console using this username and password if you want. For this tutorial and for what I'm going to demonstrate, I'm going to do that in here. Okay, what are all these things? So you have the token accessor, durations, time to live, different identities, right? So we're logged in this instance as admin, okay? So Vault replication is now configured across AWS and Azure. If you want to learn more about Vault replication, this is the documentation right here. And I kind of explained that already. So the next thing we're going to do is we're going to talk about, and I explained this if you were here for the webinar, I explained Vault like a gumball machine, right? I think about the gumball machine having these different paths and then, different tokens or methods. And I call the methods the different colors of gumballs. So that's kind of how Vault works, in that it has, these different methods and different secret engines. So with secret engines, I'll give you a couple examples. So you have the Kubernetes auth method, you're going to have the PKI auth method. You're going to have one for AWS, one for Google, different databases. These are all secrets engines that create paths, right? And then what they do is they give out different tokens that are good for a certain, have a time to live. So all those tokens are gumballs that come out. They follow those universal principles of zero trust that we talked about. So what we're going to do is we're going to look at what kind of secrets we have now, right? So if you see these little paths, like where the gumball is going to come out, right? You see how it's cubbyhole, identity, KV, PKI, sys, and then the transit. So those are the current secrets that we have, right? Now, authentication authorization. So Vault works with all your different identity systems, okay? So you might already have customers or yourself that are using Okta, Active Directory, AWS IAM, Ping, whatever it is. All those different identities, the problem I think with ICAM workflows, which is identity credential access management, is you have all these different identities, lots of attack surface area, but you don't really have a way to broker all of those things and cryptographically protect the ICAM workflow. With Vault, you do. So these are the different auth, right? So we have authentication, right, for AWS, Azure, a token. The tokens you can use is, OIDC method or JWT, and then user pass, right, which is, kind of old, using username and password, but hey, yes, you can still do it with Vault. And if you remember that photo, that was kind of the top of the iceberg, right? Username and password. All right. Now, specific to back to the trust anchors and how secure service networking works. Now we're going to look at this. And you're right. You talked about all these different IAM principles and roles and tokens, but this is what that looks like, right? This is how, Consul is able to work with Vault and have different roles on these different platforms. Right, and this works on bare metal inside of a data center that's not open to the world, but it also works on all these major cloud service providers, AWS, Google, different ones. So it's really neat to see that this runs anywhere. All right, so now that the configuration is valid, we're going to see the initial secret for Consul. All right, giving it a very short time to live. And I talked about the gossip mechanisms and gossip encryption. So there's a couple secrets that need to be secured in Consul. Really easy to remember once you take this away. So your WAN communications you're going to use your gossip encryption key, right? For your service mesh, you're going to use MTLS, right? And now with Vault and Consul, the latest version, you're able to automatically, in Cube, rotate that certificate automatically, right? So that infrastructure automation really helps. You're not having to manually do that. And then with your threat, you're able to limit the time that key is there, and you're shortening the attack space and attack window. And also, in case of revocation, you're also able to immediately revoke the key should you need to. Okay. All right, so we got the gossip encryption key. I'm checking along in the chat to see how everybody's doing here. After the gossip encryption key, the next thing we're going to do is configure Vault to support auto config. All right, so auto config is a really neat feature. A lot of different ways you can use auto config, but Vault auto config is just what it sounds like. It helps you to be able to work natively with the different cloud service providers or different methods without having, to open up another engine, right? Every time that you do that, it's able to come back to AWS and use the auth methods that already exist within AWS or Azure natively in Vault, brokering the connection. All right, this is in all caps, so you don't need to run this last command unless you have issues. Okay. So these tokens are going to be tied to Consul policies in a later assignment. All right, so go ahead and check that. That was quite a bit, but what we did right there was first we stood up Vault, right? So it's kind of chicken and the egg. There is this thing called like Secret Zero with Vault that we can schedule a deep dive into that, right? But that happened. So we got our quorum with Vault. Everything's working. Vault's up and running, right, in these different data centers. And then we use these roles, right, to take Consul, which is using service identities, and then we connected these different things so that now we have this, WAN connection. We don't have any applications up yet. The first thing we did, we stood up the VNets, the VPCs, the networking in different clouds. Then the first thing you want to do is stand up Vault, right? Because you want Secret Zero to be protected in all new environments that you're doing. After Vault stood up, then we use Consul for those service identities, connected everything in the mesh gateways, and now we should be able to hit start. All right, so we're coming up to 9:50. Before we start this lab, I want to check in for a break or to see if anybody needs help. How are we doing, Lorelli?
It doesn't look like we've got any questions in the chat, so we're good. Do you want to wait till 10 or?
I think you want to take a break. Just want to confirm the command shell commands were executed were running on the Vault system, or was it a Bastion? That's a good question. So the commands that you're running, we're actually using infrastructure as code. So those commands actually work through Terraform. If those are the commands that you're talking about. So those commands work through the API. So it's not through a bastion. Thanks, Derek. Great question. Yeah, I think we're good for a break. I know you can do Vault commands anywhere. I run them from my local. Yes. Oh yeah. So like I said, with Vault, you can run commands on your CLI, the API, or in the UI. But like what I was getting at is what Terraform does is Terraform goes out, it uses Graph and it talks to the different providers, and it's using an API to stand up and give commands to Vault. So there's a lot of scripts within Terraform that is configuring Vault. Hopefully that makes sense, Derek, and thank you, Jessica, for coming in. Awesome. All right. Yeah, I think we'll take a quick break. Lorelli, how many minutes do you want to take?
You're the one with the timeline here. Do you want to come back right at 10? That'll give everybody 10 minutes.
Yeah, how's that sound, chat? Everybody good there? Just vote if you put in the chat 5 or 10 minutes. I'll leave it up to the chat. Sounds good. What do you guys think? 5 or 10? All right, we'll go with if I don't see anything, we'll go with 10. Happy either way.
Happy either way.
Yeah,
you're doing a great job.
Okay. Yeah, no, I need more coffee. My mouth's getting dry. So
oh, I completely understand. All right, so we'll do 10 o'clock. We'll get started again.
Sounds good. Bye. Hey, Lorelli, I'm back. I have coffee and a soda. So
I was like,
good.
coffee refresh.
Yeah. How about you? Tea or coffee?
Coffee all day, every day.
Yeah. What's your favorite coffee?
It's called Bustelo.
Oh,
It's
very
like a
nice.
yellow and red can.
I had some Ethiopian coffee that is still my favorite.
What is it called? You know?
No, there's just a place in San Diego. I can point to it on a map for you. All right, I think we're ready to get started.
Okay, cool.
Is everybody back from break? Okay, good. Looks like everybody's back. All right. Can you still see my screen? Couple admin things.
Yep.
Okay, cool. We'll get started. All right, so I posted something in the chat, and I just wanted to go over this new feature for Consul Enterprise, multi-tenancy with admin partitions. When I'm showing inside of the lab, a lot of times you're just seeing that console symbol, but I kind of wanted to talk about the way things were so that we can appreciate how they are now. The way things used to be are, console operator, you'd have to have in all of our services, and most servers really have to have a quorum, right? So recommend that having, 3 to 5 different servers. So as far as running console, you used to have to run a console cluster for each one of these, instances, whether it's Kubernetes or VM. But with admin partitions, you can partition that off and only have to run one. Another thing you can reference is, how much will console scale? Well, it won't fall over. Like you can reference the million container challenge. You can have millions and millions of different, clusters. We do have benchmarks on that, and console will run all those different service networking instances. So important to take a step back from the lab and kind of understand that feature. All right, now diving back into where we were at, we're talking about bootstrapping those instances that I just showed you, okay? So when we looked at those instances, or there's just this console, kind of hand wave console picture, those are what we're actually talking about. And if we want to look at what bootstrapping is, we can use this quick shell script to look at what it is. And I've actually had this same bootstrap script and just change it for my different deployments and stuff like that. Pretty easy, but definitely, you can reference this and take a look at what that looks like. But all you're doing when we're saying, bootstrapping is just a term that we use, in operations to stand something up quickly, or how something would be stood up for day 0 moving into day 1 operations, and then you can manage and change it from there. So we're just looking at what those look like as far as the console servers. So consoles work with that mechanism, client server relationship, using different protocols, electing leaders with the quorum I talked about there. So you have your console server, then your console client, right? You can run the console agent as well. Remember the mesh gateway, when we looked at that script, the mesh gateway is what is the console service instance that is connecting the WAN. All right. Now we're going to do Terraform plan and then Terraform auto approve. And we remember Terraform plan is a way to go ahead and, see what you're going to plan to do. Also, I'm going to go ahead and add in now with, runtime tasks in between Terraform plan and Terraform approve. You can do lots of cool things and bring whatever workflow you like, whether me personally, like Sentinel is really good. You can check all this, policy as code with Sentinel in between, the plan and apply, or you could use something like, Bridge Crew or Sneak or whatever, you want to check in there to check your infrastructure and make sure that it's, up to your compliance needs. And then also internally check your Terraform if, and stuff like that. I'll hear something cool with Terraform. So you can actually see these IPs right here. So Terraform, you just do a, Terraform output file. So output TF or something, and it's going to give you the, the IP to those publicly routable IP addresses, right? All right. So now you can monitor the scripts. And then again, what we're going to do here is wait for the server to elect a leader. This actually happens pretty quick because, like I said, console can run millions of servers or instances, but in this case, it's not running that many. So it's going to happen. It's going to happen pretty fast. So let's see if we got a 200. So what we're looking for here is this 200. 200 represents okay. That means that Consul has, went through its consensus mechanisms and it's elected a leader, right? So that's cool. So we have a Consul leader. With a Consul leader, the followers can get in line and they can follow Consul, and we can hit check in the bottom right. All right, as we're going, I'm going to check the chat and see if we have any questions, but we are rocking and rolling today. We might even get done early. If we get done early, that would give you some time to go into the lab and, ask any questions, or you can also go in here and, try and play around and break things and see if you can fix them or do something like that. To me, that's really how you learn. And again, that is the best way, I think, to learn, is just by doing. All right, so hit start in the bottom right. Looks like everybody's following along. It's great. Good crowd today. In this assignment, we're going to finish configuring the primary server, okay? So now we're talking about configuring tokens and policies for federation. All right, so we're going to talk about Vault CA. This is a really, really neat topic. So when we say CA, what does the CA mean? Does anybody know? Let's see if we get something in the chat. Oh, wait. Yes, Charles is on it. Certificate authority, yes. So there's 3 types of certificate authority with anything. Just when you're using a CA, does anybody know what they are? I'll wait another 2 seconds. Leaf and intermediate, right? So there's lots of different certs and capabilities that Vault has. So you have your, your CA authority, but then you have intermediate certs and leaf certs, right, for your PKI infrastructure. So Vault can do all 3, or you could take, if you don't want a self-signed cert, like you could take one from DigiCert or whatever the case is, and then, import that to Vault and then just use your intermediate and leaf cert or something like that. All right, so we're talking about secure multi-data center. We went over that concept, but this gives you a little bit of architectural references if you need those for your program offices. And then over here is your proxy defaults. So just kind of talking about proxy defaults, because in this case, we're using the proxy of Envoy. Envoy is really popular, project. And it just talks about how are we configuring those proxy defaults. Once you get the proxy defaults, very easy to just change and make, mechanisms adapt to whatever your mission or business needs are. All right, so the Consul server is now available in the UI. Yeah, we get to look at the Consul UI. Here it is. All right, so what we see now, we have our services running. You can start clicking on things and see what it does, click in here and start messing with stuff. You can see our nodes, and I talked about those nodes and kind of showed you the picture of what those look like and how you can use, multi-tenancy. So namespaces and admin partitions are 2 different things, right? So namespaces are just what they sound like, same thing you would use in Vault and everything else, but admin partitions are what allow us to do what I showed you in that documented diagram. So those are 2 different things. So there's intentions. So the way that Consul works here is you can deny everything by default, right? So you use ACLs, you can deny by default. And then I'll give you an example of an intention. Let's say I have 1,000 service instances, but it's all for a hotel, and you have the back end, application for the hotel on the front end. So service A and service B. If you say, I want the front end to talk to the back end, then that'll scale to, all of those different instances. And then everything else would be denied unless you make an intention saying that now, the service A can talk to also service X. Okay. All right, tokens. So there's lots of different tokens that you can use, and the tokens, the way that works, I should start down here. So you have your roles, and then your roles are underneath, just like most other things with policy. So you write a policy for somebody that has a role, and then the policy is granted with a token, right? And tokens are really good for automation, because when you're bootstrapping, you can have these different auth methods that are incumbent to the roles or incumbent to policies. and then automated with the tokens upon bootstrap. All right. So now that we went over and talked about the token process and how Consul security model works at I'd say 101, 102 level, we can start to apply some of these things. All right. So if we look at the different methods that get in, we can get the token, exported and validated. So what we're doing here, let's make sure we understand what we're doing. We're taking this HTTP token that meets certain, auth methods, roles, and policies, right, that have been dictated by our, organization. And then we're taking that token and exporting it to Bootstrap it so that they can communicate, right? Let's see. Okay, we're logged in the Vault. So here's another one. Vault can create short-lived tokens. I want to reference back to the beginning where we talked about the universal principles of zero trust. We mentioned time bound, right? So time is very important. And you could think of lots of different use cases, but imagine, you have an auditor coming in, or worse, you have an attacker. If the auditor's coming in, you're not going to want them to have credentials for so long to be able to access something. There's so many different use cases, but really, I just think looking at zero trust as a methodology, you need to be able to have control across that whole, we looked at that taxonomy, right? We want to have control across the whole taxonomy and make sure that any of those cryptographic tokens that are being exchanged across the computational systems are governed, right? They can be audited and logged, and they're time bound. And that's what we're talking about right here, right? So when we take, this Consul bootstrap script, we're going to go ahead and put this in. And we're writing those different policies and roles that I showed you in the UI. And we're going to take the short-lived token and make an administrative change to the cluster. So this is just demonstrating an example of, okay, now I've bootstrapped it. Now I need to make a change. Okay. So remember when we talked about the universal principle of zero trust? So this can be exported to your SIEM system, to your logging, whatever it is. But we're getting an accessor ID, a secret ID, a namespace, a description. I mean, so you have everything that you need right there as far as like evidence of who's doing what, right? Like that is following universal principles there by being able to track all that. Okay, so last thing we did was we had the self token. Now let's add the policy for the Consul agents. Okay. All right. So always look for success. So it was written to Consul, and then you have Consul, / roles, and then agent. So now this agent has different, policy underneath the role with the appropriate token. So once that's done, we can create ACLs now. So we can start to roll back some access. All right, so that'll take about 60 seconds. All right, as I'm doing that, I'll check chat, see if there's any questions. All right, I think on this one, you can just hit check. Let's see if it'll pass. Nope, it's going to take a minute. There it goes. All right, actually, we did have another step here. Skip, if you want to check the ACL secrets and the gossip key, you can. No need to do that here. Next thing you're going to want to skip down to is tie the vault token to the replication policy. Okay. All right, now we got to add additional policy for vault. So this is the tying So Consul was bootstrapped. We gave it roles, policies, permissions, and tokens. And now we're integrating Consul into the certificate authority trust chain for Vault. All right, so the last command is Vault. Check in the chat, see how everybody's doing. Go slow. All right, so the last command, any of the ones that say check, those are just for your essay. There's no need. Instruction not gig you if you don't do those. As long as the last command you're doing here should be the Consul config, and that's the proxy defaults. So we got to correct there. So I talked about the proxy defaults, and that was with Envoy. I'm going to stop because sometimes that one can be a little bit, trip people up. See if anybody, if I see in the chat, if you're good, yeah, just let me know. If I don't see anything, move on, but happy to help debug that if needed. Okay, so in this step, we talked about in Consul looking at the namespaces. Right now, we only have a default namespace. So now what we're getting ready to do is we kind of have the infrastructure deployed. We need to prepare it so that we can just have people that are going to come in, know what they're going to want to do. They're going to want to write code and just deploy it. They're not going to want to have to deal with any of this toil. So we need to make sure that we have namespaces delegated for all the different applications that we're getting ready to field. So let's do that. With those namespaces, one of the things there is, we're going to want to give least privilege to all the different namespaces. Some people are going to be doing development. Some people are just going to be doing networking or operations or whatever the case is. So we're going to create all these different namespaces for our various teammates that have different roles within, the service networking or operations environment here. So. Okay, this one should be pretty quick because it's just what you're doing. We review the ACL policies. So you're just writing policies and roles to Consul and Vault, right? And we're organizing it. I like to tell people this kind of start as you're planning with Consul and Vault. Just kind of plan out what the project looks like as it grows on, day one, day two. How do you kind of see adding things in there as far as like if there is a new project? What is your workflow going to be to add roles, policies, tokens, and namespaces, right? It should be once you get that golden workflow with Consul, it's really easy to onboard new applications and mission apps. Okay, so after you run that, you can hit check in the bottom right.
Greg, did you see we had a Derek said receive permission denied for creating namespaces.
Okay, cool. Let's see, Derek. I wonder if he's able to share his screen, or if you can tell me the last, if you put in the chat, Derek, I might be able to help you if you tell me the last command you entered. Oh, he got it. Okay.
Never mind.
You're on it, Derek. All right. Yeah, a lot of times if we're getting the permission denied, I'm guessing one of the ACL commands wasn't entered. Okay, so now we can hit start on this one. Start the section at the top again, and it went through. Nice. It could have been, yeah, that's interesting. I'll have to check that. Thanks, Derek. Okay, so next thing, we're going to move clouds. Okay, so we're moving to a different geographic area here, different service provider. We're going to go and do the same thing that we just did. So I'm just going to roll through it if that's okay. There's really no change. And I think, but what's important to talk about here is the value, right? So there's no change to, we're really gonna have to stop and kind of think about it, because now we're doing the same thing we did in AWS and Azure. So we've come up with a workflow, right, or a process that's been accredited or approved, and it's stamped off. Hey, this is what our organization wants to do. All the checks are in place. We're meeting all of our controls, regulatory, different things, and we're just going ahead and using infrastructure automation so that we can, focus on innovation. Right? We're deploying this quicker time to market, quicker time to mission. Right? So, any questions on that? All right. Yeah, and what I mean there is, some people might still be on using, I kind of started out using, just AWS, and then, I had a need, wasn't really a choice. Hey, we have to use Azure or, Google or whatever, or some different provider. And I love them all, really great tech, but, happen to make that context switch without having a way to provision everything like this, or have a golden workflow to get all these services in production and meet all the stringent controls we had to meet. It just wasn't possible. So I think having, something that is a golden workflow and helps you to do this quicker can be really valuable for your organization. So. All right, Terraform's working. Question in the chat. Do you think Azure is going to provision faster today, or AWS? Let's see. All right, Derek thinks AWS. AWS, okay. Oh, it's pretty fast. I'm not sure what, yeah, there he goes, pretty fast today. I guess it depends on the region, right? Okay. All right, so Azure's done. We have our output, same as we had before. All right. Next thing we're going to do is, I want to take a look at this output real quick. See if we got a 200. All right. 200, 200. Good to go. Everything's intact. All right. Next thing we're going to do is check the certificate authority. And I'm sure you know what this looks like if you've ever dealt with CAs and how annoying they can be. I can't count how many times I've seen, whether it was a video game I loved or a sports channel, kind of go down because their keys or something weren't rotated, or God forbid, a major cloud service provider. But I think being able to automate all of this with your encryption algorithms is really helpful. So we checked on the CA infrastructure and the secondary DC. Now let's check our homework. Okay, so it's not healthy yet. I thought I saw 200. Let's double check. Let me know in the chat if anybody else's Azure gateway was not healthy yet. Oh, I'm good now. Mine came up. So yeah, if you did get at first, if your gateway wasn't up, that's just a real thing. What's actually happened is, those APIs are reaching out to Azure, and that machine was turning on or something inside of the building, and it just wasn't on in time when we clicked that little green button. All right, go ahead and start the next session. All right, now we're going to move the Google Cloud, and we'll have to see if this will beat both our stand-up times today for AWS and Azure, not sure. All right, so what we're going to do here is the exact same thing, but now we can see we have quite a few more instances in Consul. We have our mesh gateway, which we talked about being on virtual machines in both AWS and Azure. So we get a little bit more there on as far as metrics and tags and stuff like that. You can see some of that information and you want to poke around with that. That's fine. I encourage you to do that. Also Helm. If you're not familiar with Helm, Helm is if you think about like your YUM or your apt, it's pretty much your YUM or apt for Kubernetes. You know, it's great. The only thing I don't like about it is that it's YAML. And there's lots of sometimes errors to debug, but it is great. It is a good way to you know, package and manage your Kubernetes deployments. And we talked about using Kubernetes now for Google. So that's why we've added, now we have this Helm tab inside of here. Going through the architecture, we're going to start to get to the application stuff here pretty soon, which will be cool. So we'll actually get a, you know, a real app up in production. And what we're going to do is we're going to distribute the application. I would never advise this in the application infrastructure. It's just showing you the possibilities to have, you know, a payment system in one cloud and then, you know, a front end in another and stuff like that. We're gonna actually break it up as far as being distributed. So yeah, cool stuff. Go back to the shell and just do the same thing here for Google. Well, not really the same thing, because now we're using Helm to manage our Kubernetes deployment, but we're still managing Helm with Terraform, right? So we're using Helm, but we're using Terraform to manage and provision Helm. Okay. So we're keeping the same workflow, even though we're changing to a different runtime, we're still keeping the same golden workflow, even though first we had, you know, bare metal or something else, and now we're moving to a totally different cloud with a totally different runtime, but we're agnostic to that, and we're still using the same principles. All right, now we're going to see if the worker nodes are available. So kubectl, you might be familiar with that, but that's just a, you know, Kubernetes command that using the API that ships with Kubernetes to check on the status of the cluster. So we can see that the cluster is up and running. Let's see, okay. You may have an issue with the namespace on the cluster, but I do have a workaround for that. So if anybody does end up getting it wouldn't be here, but once we get down to your namespaces, let me know. I can let you try and figure out if you can solve it. If you can't, I have the workaround for you. Okay. Okay. Okay, yeah, let me grab a command to help fix this real quick. Okay, it's coming online. Let me share that. Yeah, okay. Oh, you're stuck with Azure provisioning. I know why. So when you get to that line, go ahead and try and set the context for the namespace. What happened is when I provisioned the sandbox, it's taken the other pools for the namespaces. So I'm just going to have you set the context to the default namespace, and then it should be good to go. I tested it on mine too. And hopefully I'll have that fixed if you do this again Saturday. Apologize for that. Let me know if that doesn't fix it. What you want to do is when you get to the command, it's the step. Let me see right here. So it ends in like when you're actually doing your Helm install, which is actually, remember, so we're running, let's think about this. So remember we said when we run Consul on Kubernetes, we use Helm, right? So that's, so we're using Helm, and that's like after Yum in Linux, if you're not familiar with Helm. So it's kind of what manages Kubernetes. So we're deploying Consul and all those bootstrapping it and doing all those different values now over here in this code. So what happened is when we're deploying it, it's going into a different namespace. So if you set that run this, then the rest of the commands. Oh, sorry. Hey, Jessica. No. So just this command again. So if you set that context and then you run kubectl create generic, this command right here where I have my mouse, then it'll work. See how my screen's like just running. It's just taking a while for GK and the pods to come online. So this, okay. Hey, skip, but was spinning forever. Yeah, it does. GK does take quite a while. One thing about Kubernetes, like if you're provisioning in the cloud and you're going to use an EC2 or a VM or something, it is so much faster to deploy. But like nothing to do with Consul, just Kubernetes clusters. They actually take a long time to come up. One of the reasons for that is just because Kubernetes is actually amazing because it does like 12 things really, really, well, but at the same time. So because it's doing so much at the same time, it does take quite a bit of time to spin up. So what we would do after that spins up is you check Consul members is a Consul command. So if you do Consul members tac WAN, you'd get to see what's going to happen now is back to the architecture. Now, when you hit that Consul WAN, you're going to see all of the different WAN connections, because if you just do Consul members, you'd see like what's inside of your LAN, right? But if you do Consul members WAN, you're going to be able to see AWS, GCP, and Azure. So all your sites. Yeah, and that's fine to hit skip too if it is taking a while. So I'm going to hit check. Yep, Helm chart is not deployed. It's just taking forever. Okay, I'm going to hit skip too. It takes up to 20 minutes. So yeah, I'll just skip that one.
Hey, Greg, you're on mute.
Oh, hey, thanks. Sorry. So I was saying next thing we're going to do is deploy the HashiCorp's architecture, and some of the advantages here using MTLS here to handle and offload all that encryption. We don't have to change application code, right? And we're not having to break the cryptographic chain when like this, remember how we showed that we've decentralized, we have this distributed architecture where the payment side is going to go and talk to the backend in a different, cloud service provider. Well, as we do that, say if we try to do that from like, different, Kubernetes clusters that require complex stitching, we lose our cryptographic chain, and we wouldn't be able to maintain that across runtimes or across clouds. With this HashiCorp's architecture, we are able to do that, and we don't lose that cryptographic chain because Consul and Vault are working together to ensure the integrity across the WAN and obviously within the service mesh, which is the easier part. So that's what we're going to be getting ready to do next. All right, so next thing is we're going to log back into Vault on this cluster. And the cool thing here is we're going to get to start to learn about Consul Terraform Sync. What I really like about Consul Terraform Sync is you used to spend personally a lot of time working with F5, Cisco, Palo Alto's, a lot of the traditional appliances and things that we would have in the data center. And, sometimes automating those changes or doing new things within some of the cloud service providers was hard. It was hard to kind of bridge the gap. So what we really like about CTS is it does just that. So we're gonna, some documents there, you can dive more in the CTS. But what we're gonna do is log in the Vault, and we will get a little bit more information on CTS here. So we can kind of see how that works. We're going to see what a configuration will look like for CTS. Create the policies. And the question here is like, why are we creating policies for Consul Terraform Sync? And the reason is because Terraform is going to come out to Consul when you have Consul Enterprise, and then it's able to tell, because remember, at the core of Consul is the first use case that Consul solves, service discovery. So when we went back to those 4 questions, we wanted to know where are all my services running. Consul knows where all the services are running. So what's happened now is because we're not static, and we're not trusting these IP addresses, we're using service instances. And now that we've deployed something in Kubernetes, everything's ephemeral. These IP addresses aren't long lived. They just come up and die. But we're still running things like F5 on-prem that are appliances, and that IP is not changing, right? A lot of these things aren't changing. So how do we bridge the gap between like these new systems of engagement and these old systems of record? And one of the good ways to do that is with Consul Terraform Sync. So we have to set roles in Consul so that Terraform can actually sync with it. Okay. So as we set the ACL policy, next thing we're going to do is create the CTS instance. Let me clear this so you guys can see the screen better. We're getting ready to go over Consul, service management. And that was another one of the use cases we talked about there, how Consul is doing health checks and able to help you to keep, everything as far as, sub-millisecond latency and making sure that all your services are always staying online. Consul Enterprise offers that as well. And we're getting ready to dive into that. All right. So we got our CT instance up. CTS instance, and this is just for demonstration purposes. You don't like need a server for CTS. This is just showing how that would work. So what we're doing now is we're showing, Consul catalog, and we're seeing the services that are working and using Consul Terraform Sync. So now we have this CTS, service up. So because CTS is up, if something changes, it'll update in the Terraform, right? So we're not having to, write down on a sheet of paper or do a ticket or try and memorize any of these changes with like, security groups changing in AWS, things changing over there. And if you think about how much change there is now in this dynamic world that has all these providers and different routes and changes, it can be overwhelming. But this gives you a system to be able to track that. All right, so we can go ahead and check. All right, so now we talked about external service monitors for Consul and integration there. There's some learn guides here, and then all the code on GitHub for Consul ESM. Go ahead and check. A couple articles and stories about 20,000 nodes beyond. Really cool stuff. Be sure to check that out. Go ahead and log back in the vault, export this token, and then create the ESM. Right. All right, we're going to go ahead and provision the Terraform in this case. So this is what a Terraform output looks like as we're waiting for that, but you can see it's going to output, the IP addresses of these ESM instances or services. All right, hang in there. I think we'll finish this one and we'll have 9 minutes till the next break at 10:50. All right, the last two things we're going to do after Terraform finishes applying here for Azure is we're going to look at the Consul catalog. So Consul catalog, and we'll check both of our data centers, and then we'll describe AWS with security groups, and that cache that we're going to get is from the Terraform state, right? So Terraform state is how all this infrastructure as code is maintained and managed, and Terraform Enterprise helps you offload having to try and build scaffolding around Terraform state and stuff like that to manage it, use it in teams, have concurrency with your runs, but outputting that is going to show us how that's actually working. All right, so there's our IP addresses if you want to check those out. Next thing we're going to do is run the catalogs. Go ahead and do that on your end if you have it. All right, so we've successfully deployed Consul ESM. And now let's see what it looks like. So this is kind of the learning moment here, but we'll get to see Consul Terraform sync in action. There it is. So I really want you to take away from Consul Terraform sync here, if you've been in the in the doing here and trying to deal with security groups, like you're testing an application or a set of microservices in this cloud service provider, and you're having to talk back to security like, I need this port open, or something like that. This is managing all of that for you in your infrastructure as code, right? So all those human interactions, it's managing that. Not only that, but now because it's in code, you can, let us do what we're good at and let machines do what they're really good at, which is like policy as code, right? Because you're managing all of these complexities in Terraform and Consul with Consul Terraform Sync, you're able to take code that actually looks at your policy and make sure that there's no violations, that you're keeping integrity. All right. So after you've described that EC2 instance and you kind of look at those different security groups and you have a good understanding, and I'll check the chat and make sure that those were some two features there, the external service monitoring and CTS. I want to make sure you're familiar with. But if you did have any questions on either of those, let us know. Thank you. Okay, so next thing we're going to do is the fun stuff. We're going to start deploying instances in our application. So we're going to start to get to see something, working after we've, spent time standing up our cloud, making sure that we have the trust anchors and, not locked in our cryptographic chain with Vault. And then we've connected our WANs. We have service performance. So now we're ready for, day 2 operations. So some things come in that are ephemeral, or some things come in that are, bare metal, or all these different things that on day 2, we're able to keep up with things because we have embedded infrastructure automation. All right, cool. So just same motion here as far as deploying the application. So each of the applications, I wasn't kidding. What happens is, because you're using, that MTLS connection on the service proxy, you're having proxy to proxy communication. So you're going to write an application instead of having to change the routes or worry about the PKI search or changing application logic. There's no need to change application logic. All you're having to do is put in the stanza when you deploy it, if it's in Helm, Consul Connect, or if you're using Envoy in that proxy default, you're just going to have to use the proxy default or make any slight modifications to that. But there's no need to change the actual application code. So same thing here. So we deployed Elastic Cache and Redis on the different cloud service providers. We just did it on Azure, and now we're in AWS, and clock's ticking to see which one's going to be faster. Oh, that was AWS really fast today. Okay, so that's up on, and that's US East. I think it was 1 alpha. Well, it's blazing fast. Okay. Whoops. All right, so we're just checking on our namespace and our cluster. So this is just using the catalog, right? So just doing a health check, checking on the service, make sure that as you're using these commands, you can learn them and save them. But all we're doing here is, just a simple API call, and we're looking at, the health, right? So you can do that for any of your services anytime. But obviously, you can also export all of these things to monitoring your applications, also really important. And this is where you're going to want to get with the solutions engineer, so we can talk to you about, whether it's memory allocation for your service mesh, or if it's, how your applications are communicating. So you can export all those logs, whether that's Grafana or whatever it is you're using to do that kind of performance, so that if you do take any kind of hits, we'd be able to help you to come up with a plan to best monitor and control all those different things that you have running. So Consul does export with lots of those, like I mentioned, Grafana. You could just do statsd if you want to do that in bare metal, and use an in-house system, or okay, there we go. All right, remind me, did I provision this cache? Let's see. Nope. So the next thing we're going to do is provision this cache, and this will be on AWS. Okay, log in and plan, then apply. check the health of Redis. So back to the diagram, we're just all those services that we looked at deploying for the application in the beginning. That's what we're doing right now. Okay. Redis is passing its health check. So Redis is going to be used for the payments portion of HashiCorp. So that's up and running. Go ahead and click on next when you're done. And we are at 10:50. All right. Perfect time there.
All right, Greg, so we'll come back at 11.
Yeah, 11 o'clock sounds good. Get some coffee, tea, or do whatever it is you need to do and enjoy your break. Thank you.
All right, sounds good.
Hey, Greg, if you're talking, you're on mute.
We're on break until 11, so another minute or two. Yeah, but I agree. It looks like he's doing something there.
Oh, hey, sorry.
I wasn't sure. I was like, it looked like you were doing some stuff on the screen. We were like, wait a minute, wait a minute.
Oh, were you able to see me?
Yeah, we could still see your screen. So it looks
Oh,
like
I see. I see. Yeah, no, I was just getting through it. Thanks. Still 2 minutes left. I'll be back.
okay.
All right. 11 o'clock. Ready to get started, Lorelli? Good.
Yep.
Okay. Yeah, so I wanted to start this session where we left off. We did talk about Consul ESM and Consul Terraform Sync. And one of the neat things here in Consul that I didn't show, and that's one reason I give you more time at the lab, you come back and check, but I think this is a really neat feature. It's the same if you're deploying natively in, if it's Mesh Gateway or if it is registered with Terraform, you're able to actually see that, the instance that we registered with Terraform versus the instances that we didn't. Or if you're using, a native method like the QBauth method or something, it'll actually show up in the UI. And I was just kind of testing that when we were on break. So where we're at now, we were looking at the lab architecture and we're coming over here. So we have Redis registered. It's also using CTS. And now we're looking to deploy the Postgres database, which is down in Azure. So in our cloud console, you can look at all this later. So you can actually see where these instances is at. And here would be your subscriptions. So you can go in and do that. But now in the shell, if you want to go ahead and run these commands, I've already done that. So go ahead and run these commands now, and I'll just pause for a minute. Okay, yeah, so it should take about 10 more seconds to deploy that Postgres instance. So that's going to actually be inside of the application architecture. It'll be distributed. So we'll have our payment system over here in Redis, our front end, and then, some back end logic down here in Azure. So it's kind of broken up. And once that Terraform goes through, we can check it. Check again. I didn't see a response. I think it was just taking a while. Check again. Okay. Seeing no response there. Look in the UI. Push this. All right. Oh, that's why. I wasn't in the right namespace. Let's see, it should be payments, products. Okay. Cool. Our nodes are up in product and front end. Okay. Let's go back to default services. Okay. Oh, okay. I see why. It's just showing as the Consul instance. All right. So we should be good there. Let's check it and make sure. Oh, it's not healthy. Let's see why it's not healthy. Check on Terraform. Okay. Okay. I think it might be on the Azure side. So what I'm going to have you do is just go ahead and hit skip on that for this challenge. Unless if somebody got that one, got their Postgres database to get healthy, let me know. If not, I'll hit the script and see if that resolves it with the backup Postgres server.
I just had to wait a minute and then it eventually came up as healthy.
Okay. Yeah, it was just taking longer than I wanted there. So who was that it came up healthy for? Charles?
This is Charles.
Okay. Yeah, that's why I wanted to start. I don't know if you saw me, but I started before break because I was realizing that Redis on AWS took under 20 seconds and the Postgres service on Azure was taking like 10 minutes. Some of my last tests. Yeah, if you saw when I ran this command too, how I knew, no, I don't want to do that. When I ran this command, the curl command that was checking the service health, if you see, this is good. I'll share what I was doing during break. I ran the command and then I saw that there was a bracket or like a no response that I wasn't, where are my services running? Are my services running? So in that way, I kind of used, the ESM and I was like, okay, well, service isn't running. Something's wrong. So I was looking around in the Consul UI. I was checking through namespaces and then, I looked at the Terraform code again and remembered, oh yes, this is the one that, it was just for whatever reason on the Azure side is taking a long time the spin up. So the actual physical node was not healthy. So that's what was going on there. Now, because we're running, I think I spun up like 30 sub instances. Maybe in that region in Azure, they were not getting that much usage, but because we're all doing the lab at the same time, it takes longer, lots of different factors there, but so, all right. Okay, I said skip. Hey, Lorelli, as I get that one finished, I know it is lunchtime and this Postgres database seems to be taking a little while. I know some of the students have got past that, but I don't want to waste anybody's time. So maybe we could just do come back at 11:30 when we get that resolved and give people a quick lunch break. We're still ahead of schedule, so let's just take a break, come back at 11:20.
Okay, that sounds good to me.
All right.
I will add a note in the chat too, to make sure that everyone knows.
Okay, thanks. Yeah. And I would say, hey, if you're able to skip past that one, go ahead and either, I know some of them are working, but Postgres is taking a while. So once you get past that one, just wait there and then we'll reconvene at 11:20. Thank you.
11:20 or 11:30?
Oh yeah, sorry. 11:30.
Okay, perfect.
All right, 11:30. Welcome back.
Ready?
With our extended break, I hope everyone was refreshed. 4 hours is quite a long time for a workshop, but I really appreciate everybody getting involved in the chat. And Lorelli, thank you for hanging with us today. Really appreciate
Of
that.
course.
All right, so we'll get started back up if that's okay. All right. So what we left off with, and we were kind of talking about, or solution-wise, is when we start to leave a lot of these service mesh solutions, we don't have a way to not get around complex stitching or these kind of one-offs, whether they're in AWS or Azure, like with terminating gateways. So when you leave the mesh, how do you gracefully leave the mesh, but make sure you're doing so and you're capturing any of those changes, the security groups or some of those traditional mechanisms, and you're also ensuring the cryptography is there. So in this case, we can kind of see what that looks like. Let's SSH into to this instance. You have two shells here. So in one shell, you can go ahead and do that. And then in the other shell, just go ahead and log back in the vault and then export that token. All right. So if you take a look here, you're going to be able to get a chance to see what that looks like how that is actually playing out. And I would encourage you to do that, as you experiment with this for the rest of the week. All right. So next thing we're going to do is kind of the same as far as the workflow goes with the TGW here. So we'll take that terminating gateway, and that's done. So now we have roles, policies, and then we can automate with the tokens. All right, so let's go ahead, and now that those things are in place, let's go ahead and launch them. So we'll deploy that Terraform. Come back over here to the shell while we're waiting and just see that the task was completed, and kind of checking out and seeing what's happening here. We can quit that process if we, if you want to. You can do that with Control-C, of course, or whatever hotkey you want. You can come back over here and make sure this is approved. Oh, it's just waiting. Terraform's thinking about it, and it's running. So when you see data in Terraform, a lot of times people ask me, hey, I have some infrastructure that we deployed using ClickOps or whatever the case, or already existing infrastructure. And I want to get started with Terraform, but I'm not sure if I can import existing infrastructure. And the answer is yes. A lot of times when you see that data, that's saying that, hey, there's something that's already existent. So you're using like Terraform import mechanisms to kind of do a data call and understand what that is, and then pull that back into Terraform so Terraform knows it's there. So hopefully that solution, you can remember that and pull that nugget out as needed. If somebody's looking to use infrastructure as code, but they already have things in place and different cloud service providers are on-prem, and they want to get started, but they're afraid that they'll miss things that already exist. They can easily do that with Terraform. All right, so this as these Azure resources are standing up, we'll just go ahead and wait on that. And then we're going to run that same command, and that's the Consul catalog. And I just want to hit on that again. So things are registered in the Consul catalog, right? And then those are in be able to called on in the service registry. And what's happening there is those IP addresses are being mapped to a DNS name, right? So the things that are one ephemeral, right, like short-lived, they're able to be monitored. You get all the features that we talked about the first question of today, where all my service is running. And then, how do I connect those? How do I secure those? And how do I automate those? Those are the 4 questions that after today, should have no question about how you do those 4 things. All right, so let's go ahead and check on the health. Of course, it won't be right. Oh, there you go. Good. Look, Postgres. Well, thank you, Postgres, for giving us an extended break. I really appreciate that. I don't know about everyone else, but I got a full meal, so I'm now feeling energized. So thank you, Postgres, for taking a long time. All right, so let's check out CTS. And anytime we're using, so this AWS EC2 describe, if you're running like an AWS command just on your other terminal and you're like, what is that? How does that work? That's the AWS CLI. That's all that is. That's not like a, that's just a cloud thing. Each cloud might have like something that you can install and then run that local CLI. And that's all we're doing. And we're doing it to describe that instance. And when we look at the instance, we're able to get those things back. And as far as this description here, we can see that it's added by CTS. And again, when we look at the console in here, you also see that icon. So that's really helpful, right? So we know it's in the service mesh. Now it's in the service mesh with the gateway and it's registered with Terraform. So that should be pretty helpful for us there. If you're looking at a lot of different service instances and you're going down and trying to make sure some of those things that you're already using traditionally are now registered, like your F5 or your Cisco appliances in Palo Alto, you want to make sure those things are pulled into the fold of all this new stuff that's going on in the cloud. Then that's as easy as running that and registering them with Consul Terraform sync. Okay, so with no questions there, let me check on the chat. Glad to see we have some more people joining us. I'll wait here, but you should be able to hit check. I'm not seeing any questions. Thanks for that. Okay, excellent. All right, I think we need to get HashiCorps up and running because my coffee cup is running low. Order some coffee today. Okay. All right, so in this, now we're going to get to talk about Nomad. All right, so what is Nomad? Nomad is another look at things. If a lot of times you can run Kubernetes, and I said before, Kubernetes takes a long time to stand up, and it's great. It does 12 things, but like some of those things that it does so many things. For instance, by default, the Kube API server is not encrypted, right? So like not managing secrets, and it's doing a lot. But if you just want to run like homogeneous workloads, and you have a really big need to run lots and lots of different things and orchestrate them, Nomad can be a really good solution for that. So in this case, I'm going to use Nomad to provision and schedule services, just because it's a lot easier. Could I, write a bunch of bash scripts to do like bin packing and orchestration and management, or could I just use Kubernetes? Well, I probably could do both, but I couldn't just use Kubernetes because some of the things that I'm running are not in Kubernetes. So Nomad also becomes a viable option if some of the things that you have will never be in Kubernetes, for whatever reason. Maybe they're just old applications, or they're on-prem and they can't reach out. I don't know, but in this case, I'm using Nomad to orchestrate some of these things. Something really neat with Nomad is it also works with Consul Connect, as you can imagine. Works really well together. Oh, I bet my mouse died. That's pretty awesome. Let me just use my MacBook. Sorry about that. Okay, so let's see. We have to plan and apply again. Let me try and fix my mouse. Sorry about that. I have to type out all my commands now. Let's see if I can fix this thing. Okay, I fixed it. Sorry about that. A couple of things you always have to keep. One of them, spare batteries. All right, we already did that, so we're good. Sorry about the mouse distraction. Hopefully everybody was all right with, hopefully everybody's okay with deploying that. I'm checking the chat kind of as I do this, and I'm not saying anything. A couple of people chuckling at my mouse dying. We're gonna have to have a funeral here for my mouse. I think it's shot. Yeah, it's on its last leg. Okay, there we go. So we're using some of these data sources, and that's looking good. Okay. Okay, we have phishing. All right, so we could access the Nomad URL if we want to. You can do that in another console. Not going to really mess with that right now. Just know that it's running. But if you do want to check the services, you can do that right here. The Nomad UI is also really neat. You're able to see all the different workloads, and you can see here we have Nomad running with the Nomad client. But yeah, if you want to pull up the Nomad UI, I'll go ahead and just do that for you real quick. Run that. And then you'll be able to pull that up. So there's the Nomad UI. I'll go ahead and click on it for you so you can see it. So there's Nomad. You can see where your clients are running, servers, your topology. It's really neat because it just gives you your allocation, so you can make sure. One of the big value points here that I saw is if your CPU utilization across your fleet is like under 20 or 30%, you could really potentially be wasting a lot of money on oversized cloud spend. With Nomad, you can use it for bin packing to make sure that you're getting the most out of what you need before you scale out for no reason. So that's really neat. Jobs are so easy to write and use. That's one of the things with Nomad I liked. I know we have cloud certifications for Terraform, Consul, and Vault. There's no certification for Nomad because it's really JSON files are so simple. Just really plain English, kind of tell it what you want to do, and Nomad will do that for you. All right, so there's Nomad. So Nomad's orchestrating things in the background for us, and we checked on the service catalog to make sure it's running. We also visually inspected Nomad in the UI and glanced at the UI real quick. Let me know in the chat if you have any issues with that, and we'll go ahead and move on. We'll start up the next lab. All right, so now we have multiple schedulers working. We have Nomads, managing things that are not in Kubernetes, and then we have Kubernetes managing some things here. So we're going to provision our K8 scheduler services, and we're going to do that in Terraform. That way we have a single control point to provision infrastructure. No matter what it was, we deployed Nomad with Terraform, and then we're also going to deploy Kubernetes with Terraform. All right. It gives us our certificates as output. Next thing we're going to do is our front end using a little bit of React. We're going to go ahead and deploy that. And just as you can tell here, when you start to see kubectl, so changing the context and everything like that, we are using Kubernetes. So once that's happening, we're offloading and using kubectl. Vault and Consul run natively, with Helm inside of Kubernetes. So you're able to leverage both Helm and Kubernetes again to be able to do that. Doing a quick check here. Okay, everything's looking good. Next step is, so we have the React cluster, and we're also going to use Graph inside of the application here for the logic of HashiCorp. Deploy Graph. So Nomad will be doing all the scheduling on these services. Like, let's say it's Friday at noon, and that's when everybody orders coffee, and we have a sudden uptick, and all of our students are like, Greg had us go through this class, it's 4 hours, I really need more coffee. And everybody goes to HashiCorp and starts ordering more coffee. Nomad will handle that for us, and we don't have to worry, the site won't crash. Nomad will keep everything up and running here for us. Thank you for that, Nomad. I know you're going to need some coffee. So that's all good. The Helm chart is not deployed for GraphQL. Redeploy Helm, redeploy with Helm install and upgrade. Okay. Let's go ahead and do that. We'll have to go back to, we'll just skip it to make it faster in case it's gonna give me a glitch. I'm curious if anybody else had an update there, but I think I put a Helm update, Helm install update. Yep, I'll just skip it. I probably made a mistake. Yeah, just skip through that. Mine didn't clear it. Yeah, just go ahead and skip through that. I think I just had a do a Helm update or something, but it's probably just going to be quicker the skip it. But I think what happened there is probably just having the latest version of Helm inside of that script. I'll take note of that real quick and try and add that in case anybody else, you can reach out to me if you're doing that lab, and I'll see if I can get that updated today. Okay. I wanted to click on the Helm and look at it, but I'll let this thing finish loading. As I go, if there's any, yep, thanks for that, Jessica. If there's any questions in the chat, go ahead and post those. Again, we can talk about that. Same here, skipping. Okay, I think everybody's skipping. Yeah, as we go. So I think that also when you look at Helm and using Helm, I was curious, kind of polling in the chat, how many people here are familiar with using Helm? And have you ever deployed Consul in Helm? Okay. Yes and yes. All right. Awesome. Yeah. So there's, you know, you can follow that closely as far as the updates. And I think you'll see that the Consul K8 team always willing to meet and discuss, but we're always getting lots of changes, lots of updates, lots of new features. So I think the best thing to do in this case, like if we did want to get this, you know, solved, what we want to do is go in and check the chart and look at the chart or the version. So we would just come over here and look at, you know, what version of Helm was running in this case, and then update that chart. And like I said, we could do that, but that's be a little bit of yak shaving as far as the lab. So I just kind of wanted to show you the point here that what will happen is we're going to rely on Helm to check and make sure whatever version in there is the latest, and that we update it. And that's one good thing about immutability. In this case, what we can do is actually take the Helm chart and the Terraform. Once this script is you know, run and updated, it will check against that and it'll just resolve it for us. But what that script is going to do is it's going to go and check those things instead of us doing it manually, which would take more time. So as long as you have a you know, a script that can check for that, it'll save you time and help you get up and running there, Jessica. Getting the service mesh working has been interesting. What kind of issues did you see, or what kind of troubles were you having?
I'm getting the, so it's running as a container. The service mesh is running as a container. I saw a note in one of the docs that the service mesh and the sync catalog cannot run for the same service. And trying to pull services out of the service sync has been difficult. And I haven't been able to get Consul to deploy its injector alongside another service. So it's just been a process, but that's not necessarily the Helm chart's fault.
Oh yeah. Okay. Yeah, I'd love to dive into that with you sometime. And yeah, just be sure to shoot us a message, and I'd love to take a look into what's going on there. So yeah, thanks for sharing that. When you say were you talking to the Consul registry, or what were you trying to do there? I didn't really understand.
Yeah, I'm trying to, so I'm deploying a service that runs as a 3-node cluster, a stateful set.
Mhm.
And it has communication between each of the nodes deployed. It has a service for communicating into that cluster, and has a service for communicating out of that cluster. So it has 3 services running. The feedback I'm getting from the console injector running alongside this deployment is saying that it can only manage one service. It can't manage. So, like, I've asked for confirmation from our POC um, with HashiCorp, but it seems like it can only manage one service for a deployment. But I have 3 different services, so I'm just trying to figure out a solution for that.
Yeah, yeah. I'd have to look a little bit more into the complexity, but I would like to at least give you something here just for education. Everybody's on. I think that the 3 different services that you're running, it kind of sounds like it's a little bit, in this case, I don't know, is it kind of broken up in the microservice architecture everywhere else? Am I understanding that correctly? Are you trying to, or is things tightly coupled still? Is that what's going on?
When I say service, I mean a Kubernetes service.
Okay.
So it's each container does its purpose, but it has like 3 different ports open to facilitate 3 different types of communication. And I'm getting issues with Consul saying that I need to select one of those services for Consul to manage, and it doesn't seem to be able to handle all 3.
Oh,
So because all communication, when you have the injector run alongside the, you have Envoy that does the proxy, and you have the injector that's managing certs, and all communication in or out of that cluster, in or out or between nodes in that cluster, is required to go through that Envoy proxy. But it's saying that it can only manage one of those services.
right. It might sound like you're having an Envoy issue, which could definitely look at if you're talking about Envoy. But something to be aware of, we're not going to get into today. Consul does have a API gateway as far as like your north-south traffic. I think what you're talking about, because if you were relying on now you can use with Consul, you can rely on just kube DNS because you're using transparent proxy, right? So as you're doing that, you have no need to change any of those services or applications. So I'm not sure what version of Consul you're running, but you might want to take a look at that at some of the changes that have come up. Hopefully that's helpful, Jessica. Thanks for bringing that up. All right, so great question. I'm glad to get some live, Q&A and discussion going. So thanks for that. Next thing we're going to do back to the lab is for each persona, we're going to configure intentions for access, right? So that we have least privilege. The next thing we're going to do as far as product development is grant access to the front end or the APIs, right? So as we grant access here, we'll see that we have allowed front end public API access. All right. All right, let's check that real quick. Oh, let me get the contact info. Definitely, Jessica, follow up with me. I'd love to jump on a call and try and help you out. Yeah, that goes for anyone. If anybody wants to follow up for like a one-on-one solution session, please just post in the chat. I love would love to do that and learn more and try and help you get up and running with your apps. All right, so now we're doing a Nomad run. So we're doing the payments API. Like I said, this Nomad orchestration stuff is just really simple. like Jessica brought up a great point. Kubernetes is an amazing system, but it can be really, really complex. With Nomad, you really don't have any complexity because it doesn't attempt to do 12 things at once. It just does one thing really, really well, right? So we're just waiting for that service to come up and see how, if you look at Nomad, so let's just do Nomad. Quick. Aaron jobs. Okay, so it's running, it's priority 50. Let's just check on it. 2 desired. Okay, cool. So it even shows the test of a failed deployment, and then it basically schedules if any of those services like come offline, then Nomad's going to reallocate and then bring back up the payments API. So that's kind of cool. All right, can't see. All right. Let's see if it's registered with Consul. So Nomad's up, like the payments API is up. But what I'm checking here is I'm looking at the V1 health service. And you know, I'm just piping out the JQ, the C. Yep, there it is. Okay. So it's up and running. And that is pretty cool. So now we're doing is a simple orchestration with Nomad, right, for the payments OPI. And then we're connecting it with Consul, right, using the surf mechanism. And we're passing this output, these agents, to make sure things are live and reachable. And we're getting back, you know, that output of those communications, those HTTP communications. We got our 200, you know, status okay, everything's up and good and running. So that is all good. Now we can advance to the next lab. Sorry if you see me like leaning over, that's because my mouse decided to completely die during the workshop. So sorry, like right in front of the camera. Sorry about that. Yeah, any questions with the Nomad UI? Inside of the UI, you can click right here and it goes to like all the use cases. One thing I was really excited about, and I know we have HashiCorp Europe coming up. I would invite everybody to go attend and check it out. But I know last HashiCorp I entered to win myself because I love HashiCorp swag. I work here, but I love it. They had a thing where you could do like just write a Nomad pack. So this is, remember we were talking about Helm. Nomad pack's kind of like Helm for Nomad. So you can write your own and community repositories here. But if you want to deploy apps or sample apps, you can do them really easy using Nomad pack. It's similar to Helm, but then you don't have to use YAML. You know, you can just use HCL. So, okay. All right, so what we're doing now is the product here. And again, I think the learning or the process here is once we have this down, you know, whether it's payments, products, change this UI, deploying these applications and connecting them, once we figure out how and we're educated on what that golden workflow looks like, it's really easy, right? Because we have immutability with Terraform, you know, all that advanced cryptography and stuff is handled with Vault. And then we're just inside of the service stanza with Consul service mesh uses Consul Connect, right? So if you're running that inside of a Helm chart, inside of Kubernetes, all you're doing is put Consul Connect, right, in the stanza. And maybe sometimes your Envoy, like if you are running it on a VM or something, there might be some service changes you need to make to Envoy, like it was pointed out earlier. But definitely Envoy's got a really good community, really well used, really popular proxy. So there is lots of support out there for that. Okay, so as we apply this Terraform, I think the next thing to do is just check the product API service. As we do that, we can kind of look at the application traffic flow again, just so we understand that. So the user is going to come and they're going to be routed to the GKE load balancer. They'll get to the front end GUI and they're going to see, to order their coffee, which is going to, this service communication, the front end, the service proxy will be communicated with Envoy. This will be encrypted with MTLS from Vault, right? And this is running inside of Kubernetes. So it's not using Kubernetes default service mesh solution like Istio, right? So it's using Consul, right? Because that's the complete secure service networking solution. We don't want to be using, the something that's not encrypted. We want to make sure everything's encrypted at transit at rest and following universal principles of zero trust. So we're going to use Consul here. We're just leveraging Envoy as that proxy. We're going to use Envoy here, even for the mesh gateway. And then we're going to route them to the payments API, which is another cloud service provider, and then back down here to Azure. All right, so that's done. Let's check and see if the payments are up so we can take all those credit cards. All right, so the product, sorry, not payments, the product API and sidecar proxy are, both of those services are up and running. Go ahead and check that. Good to go. All right, now the front end. So our users can visualize the HashiCorp's application. Let me check in the chat real quick and see if anybody's stuck or just following along. Nope, everybody's good. Okay, so ingress. See apply. All right, there's the payment API. It's registered with Nomad. It's defined in proxy. Intentions. Okay, so there's a deny intention. All right. Go. Okay, let me see if I can fix this. I'm going to change the context again. I think the context might be getting stuck. I'll post this command again if it works. Whoops, gotta move this quote. Yeah, so what I'm going to try and do is change the context. I see the namespace is not found again. Because I think before, if you remember, I switched it to the default namespace. So again, in Kubernetes, this is not like a namespace in Consul or something. It's just namespace stuff. It's part of the lab. Okay. So it modified the GraphQL namespace. If that doesn't work, I'm going to skip it, but I think that's what the problem was. Let's see if that works. Okay, that was too fast. Let's see. Okay, the namespace error. Yeah, go ahead and skip that one. I'm still having the error, but all that would happen there is that application, it'll resolve it on the back end with the skip script. But what happened there is the namespace is stuck. And that's just a thing with this lab. Yeah, just go ahead and skip that one. here's the command that I added into there just for your reference. So you guys can see it. I think because this namespace is already taken, it's not going to let me switch again. But if you had that kind of issue, you could probably resolve it with that. That's more of a Kubernetes thing, which can get a little complicated. But I think what's happening is because I pre-warmed the lab, it already had a namespace and it wouldn't let me use the namespace again when I'm going through it as the instructor, or as you're going through it as the student. So I have to think about a way to rotate the namespaces for us. So Lorelli, I'm thinking that based on we have about less than an hour left, I think we can just kind of smoke and smoke through and get as far as we can, because we're scheduled the end here at 1 o'clock. We should be right on time to be able to get HashiCorps up and running. And if not, again, I said this is good till Saturday, but I don't think there's a need for any other break unless you do.
Okay.
I mean, what do
No,
you
I
think?
think that makes sense.
Okay, perfect. Really appreciate everyone hanging in with us here today. This is one of our longest workshops that we do. We have lots of other workshops that are kind of shorter, and they kind of focus on maybe the 100 level, 101, just on one product. But this was kind of the second part to a webinar that we had